ago, and I'm just wondering, like, what's taking so long? Justin had a list.
Right.
I know we had to look at some of the stuff Ed had, but that's got nothing to do with the stuff.
Right. They were going to archive much stuff past, right?
Yeah.
That's right. Give me a second, let me get my tip out first before you come by.
You need the apron too.
Good luck. Well, this is the group arena, this could be fun.
Well, is there anything just this doesn't look good? They're meeting tomorrow with this. They won't. This won't pull back the pension policy. They won't disengage.
What's that mean? We weren't at the meeting. Are you talking about the versions that they did?
The retention, see if we can please, we are running very close to the maximum limit with no way to remediate since the retention policy is superseding the version.
I told me it's a little late.
Site storage metrics.
It's not, no. Yeah.
We're good. So you weren't trimming off anything anymore, right?
Do it myself.
But can you?
Of course.
In here?
I can look.
Because Lynn wouldn't be doing that, right? We're 99.99%.
I know.
He said no. I already did that for one. I did that for one.
Yes, I got too. You know, I've seen people with them, but I haven't seen where they were.
Yeah.
She's a runner too, so she'll like do a workout.
That's right.
There was not, I saw nothing for me. Yeah, you can tell. If somebody's from Kansas City, they will never say they're from Kansas City. They will say they're from Kansas City. No, they want you to think that you're in Missouri, they're not in Missouri. Yeah, so.
On leveraging classification systems for advanced
Restaurant there, right at the.
transportation design and construction projects. And I'm going to let our presenters present themselves.
And Alexis.
Well, good afternoon, everybody. Thanks for joining us. I am going to still a little method that my friend Eric Solwick used yesterday during our session. And so just to make sure that people choose the right session this afternoon, let's go ahead and clap really hard and get really excited about being here today. So, okay, 2, 3, 1. All right, my name is Alexa Mitchell, and if you don't know me by now, let's chat at Hospitality Room. I'm with HDR, Transportation BIM Program Manager, and today I am joined by these two awesome guys that I'm going to let themselves introduce.
Hello everyone, John Reese with HDR. I'm a Senior Transportation BIM Specialist working in the Life Systems team, working with the PennDOT team on their digital delivery directive. Scott McMasters, I'm PennDOT's Digital Delivery Design Lead.
He is much more than that. He makes magic happen. So, all right, is this mine? All right, you know who we are. All right, so we have quite a bit of information to share with you today. I'm going to start with just some general concepts and talk a little bit about why we need standardization. And then John is going to talk about some of the examples that exist today for classification systems and the benefits of data classification. And Scott is going to close us with a call to action and why we should get together and get things done. And if we have time, we'll do some Q&A. But as you know, if you have been to IHEEP before, the Q&A happens even much later in the hospitality room. So, you know how it works. All right, so some general concepts. Let's start with the very, very basic. I hear some terminology and people are like, I don't even know what that means, so let's do that first. So, when we talk about classification systems, we're talking typically about very specific terminology, one of which is taxonomy. It's just a really fancy word to say, this is how I classify information. I put it into buckets, it's a group of objects or whatever, and it exists in many industries, right? Science, genre of things and that sort of thing. Ontology is another fancy word that you hear a lot. And it simply means that, okay, now that I have all these terms, all these buckets of information, I'm gonna study how I put them all together. How do they relate to each other within a particular domain? And then, so what we have here is classification systems need both things. We need to define those terms, the synonyms, and what bucket do they fit in? What classes do they fit in? If you were in Terry Walters' session this morning, he talked about those buckets, right, of classes, of things that are similar. And so we need both of those things. We need the taxonomy, but we also need the ontology so that we know how to relate those terms to each other in a variety of ways, because that's just the way databases work. Okay? So, there are many types of classification systems, and I'm going to talk about the two most common ones in the way we organize information. If you think about a family tree, that's hierarchical. There's parent-child relationships, and then there's like the faceted. And so let me talk about the hierarchical, right? Parent-child relationship. They're used a lot in science and geography and those types of different things, but one of the things that is difficult about hierarchical classification systems is that they're too rigid for a domain that needs flexibility, like transportation, for example. Faceted, on the other hand, you can have multiple facets expressed as tables, perhaps. And the tables can be connected through relationships. And I'll give you some examples here, like online shopping, versus going to the store and look for information, look for products, right? So I really think that faceted is one of those things that is perfect for a domain that have a lot of things in common, but still need flexibility so that you can add your own spin on things for the things that are specific to you. So, this is an example of a hierarchical classification system. And I like to think of going to, I'm a shopper if you haven't told me, you can guess, I like to shop. So let's go to the store, and hierarchical classification systems are great for human interpretation. I kind of follow the line, right? I understand how things are organized, and I would think this is the way that we use today in analog. This is an analog classification system, very similar to what you do with your plan sheets. How do you organize your plan sheets? You organize them by type, so that somebody can grab a set of plans today, whether it's a PDF or a printed plan, and you can flip through and go to traffic, and boom, there it is. You know how to find it. It is easy for a human to go and interpret those sheets and read what the information is. So it is a classification system, so we are using something similar. However, how do you do the same thing with an online experience? A digital classification is what online shopping is all about. So you have multiple tables that are somewhere in a database, and they're related somehow through a variety of relationships. So that if I need, I'm looking for shirts of a particular type, now it's a different search. I'm not in the store, and then I can't really see the neatly packed shirts that I am looking for, because my son sent me for, hey mom, I want a red shirt, because I gotta go to homecoming or whatever. But now I'm shopping online, and the computer is doing all the hard work for me, and the computer knows what the results come back because I put very specific words that I'm looking for. And that's only possible if you have some kind of table classification. All right, so I'm here to say and to encourage people to think about why we need a classification system in transportation. We've been talking about models, legal document, we need consistency, we need repeatability, we need to be able to reproduce results. But we need to agree on how we're going to group our classes. And if the objective at the end is operation and maintenance, we need to think about asset classes. And I think that Tricia Stefanski did a good job during the panel discussion to talk about which classes. We do this. It's not like we don't do it, but we just haven't come to an agreement on what is that 80% that is coming to everybody. Okay, and so I think that if I compare hierarchical to faceted, I still think hierarchical is blank sheets for me. So do we need to stick with what we've always done, or do we need to look at a new way of organizing information? That's the question for you, right? What do we need to do first? All right. So, I've been talking about standardization for a long time, and I've heard so many different people say, no, we can't really all standardize on one thing because we all have very unique situations in our state, and so there's no way we could ever come up with a national classification standard. I'm here to say that's not true, because we've done it. I was talking to my friend Jen earlier today. We've done it for ITS already. We've done it for other things, right? And so it is possible. It's not an easy task, though, right? Because we all have to get in a room and fight it out and discuss what classes do we all agree on. How do we organize information? What buckets are really the broad, right? At the very top, what is that bucket of information that we need? So it is not an easy task, but it is possible. But why do we really need it? Well, there really isn't one formally created for model deliverables or BIM, digital deliverable, whatever we're going to call it today. But there isn't one for infrastructure. We don't have tables of infrastructure objects that are classified by a particular class. We have it in other areas. Buildings have done really well, but we don't have that. And the truth is that we are generating so much information, and we need to be smart about the information that we're sharing with one another. Because not everybody needs the same information, not everybody wants all the information. So how do we get to the point that we can organize information so that it makes it easier for us to parse it out to the people that need what they need to do their job function? But I can tell you that as an engineer, I need to know certain information that my friend Matt, as a contractor, didn't need it. He needs information that is specific to his function. And if you are in operation and maintenance, your function is different than my function. So you may need some of the information that came from me, and other information that you need doesn't come from me at all. And we need to understand those kinds of things. And, I find myself talking to people about trying to do digital methods following the same logic that we do for analog methods, and that doesn't work. Don't try to fit something into something that doesn't fit, right? So that's another reason. But if we are ever going to be able to achieve model is legal deliverables, we really need to be consistent. It doesn't matter who the designer is, you're always getting the same product over and over. It's consistent over time. It needs to be able to be repeatable and reproducible. And people say, well, isn't that the same thing? Well, no, it's not the same thing. Repeatable is, I create a procedure, and I follow my procedure over and over and over, and I always get the same result myself. That's repeatability. But if I want to reproduce that process. Now that I've vetted that it's repeatable by myself, I always got the same answer. Now I need to be able to have a group of people follow the same procedures I just followed and get the same answer. That's being able to reproduce procedures. So it needs both. You need to vet the information, the procedures that were repeatable by one person, the same person, do it in the same way over and over and over. And once you have vetted that process, it's ready to go to the next step, which is, now let's try everybody follow the same procedures and let's see if they actually can reproduce the same information. And so that is the main difference between the two. And traceability. If you were at the workshop earlier today when we talked about 3D model review procedures, traceability is super important. Today, it's sort of easy to trace your decision. We have either printed or electronic paper, whatever you want to call it, and you can go back to a drawer and to a record and trace that decision making. Who reviewed it, when they reviewed it, you know, you see all the highlighted items on a plan sheet, it's easy to do. But how do we trace all the levels of information, all the decisions that we're making, all the snapshots of a particular digital deliverable that is evolving over the life cycle? How do we trace that today? If you are going to be audited, how are you going to reproduce that information that is digital and it's gone? So classification and standardization of how we classify information and how we deal with digital information is extremely important, and classification systems is one of those foundational things. All right, and that's all for me.
That's not, you don't get out that easy. So Alexa talks about what it is and why we need it, basically. Why don't we have it? We don't have it because we live by a lot of different things. And we've grown accustomed to living by these things. They serve a function for us. They've served a function for years. There's much more than what you see here. But these things give us structure in what we do. This is what we follow. These things are easy to know. But as Alexa said, this is all manual. This is basically us looking up things in these systems and following that track. Now here you see at the very bottom, state payout categorizations. This is one reason why it's been really hard, because every state has their own categorization system that they've developed. And it's the way they track their payouts. And it may not be as functional as it needs to be, but it serves the state's purpose today. Another thing we might take a look at is the GCC. Everybody's familiar with that. And I bet in this room, I hope in this room we have someone that could just give me one category in the GCC. Just a category.
Regulatory signs.
Regulatory signs. Anybody else have one? Warning signs. Got it. Now, by chance, could you give me, say, one of those regulatory signs? What their code is?
R1 stop sign.
R1-1 stop sign.
R1-1. That's right. Very good. R1-2 yield. Now you know that because that's consistent. And W. Warning Yellow markers at school. Why isn't guide science cheap? Anybody wonder why guide science is cheap? So we developed something, and like you said, telephone traffic, you know, they have their set of standards. We have it for the UTCE, and it is usable because it's consistent and it's predictable. You know that. Software companies need this kind of work. Now, how many software packages do you know of that actually give you a sign, access to signs to place on your projects? SignCAD? How do how do you think it goes out and finds these signs for you? It's got a database, it's got this graphical database, it's got these objects, and all you do is I need that R1-1. Stop sign pops in. Yep. It works. Consistent and predictable. Remember, consistent and predictable. That's what we need. What are the other industries doing with standards today now? You've probably heard there's a lot of talk about ISO. Industry, our International Organization for Standardization, which they flip it and call it ISO. That's another one of those head scratchers. But anyway, it's easier to say ISO. They are into a lot of standards. So they touch a lot of different industries that we have. Architecture, engineering, and construction, AC. They've been working off of the CSI spec, the uniform master format, Omnibus. And that's worked quite well for them. That integrates with their software as well. We have, let's go back to that, sorry. Aerospace has theirs, and automotive has many standards, multiple standards that they work off of. So let's look at CSI spec and just take a glance. We're not going to spend a lot of time here because you're probably familiar with it, with the uniform app. And what they've done with their spec, I don't know if any of you are aware, they started back in 1949 after World War II because of the housing boom with all, what's going on. They found out that they needed a way to organize what they were doing and make it consistent. So what they did is they come up with these different areas, like a uniform is for design and estimation, mainly. These things are used for other things, but they categorize things for that purpose. Master format is for construction takeoff and estimates for construction, mainly. And then we have Omni-class, which is the life cycle, and asset management. That's where you find your others. Now, when we're looking at these, Alexa talked about a faceted and a hierarchical. Yeah, it's hierarchical. Hierarchical and faceted. So when we look down through these, uniform format is hierarchical. Master format is hierarchical. But Omni-class is a faceted system. It's a set of tables that allow you to pick from them. Over the pond, we have UK has the national specifications, and they have a Uni-class that is structured a little bit different, takes in a lot of what this does, but that's what they use over there as well. So if we look at this uniform app, just the way it's structured, I'm not going to go through this, but you'll see it's A through Z, not sequential, but they've classified this into different areas to service different parts of what they do. Now think about how we can do that in transportation. We have basically some of these same areas, but this is specific to architecture. And you can see that it's shell, interiors, services, things that doesn't show up very often if they're on an infrastructure project. But they do have site work and special construction and demolition. Maybe worded a little different, but it contains a lot of things that infrastructure uses. And go down to this a little bit more. Master format is like I said, the structure takeoff, estimate portion. They structure theirs a little bit into divisions. And the one division that, the divisions that we would think consistent with what we do in infrastructure is 31, with earthwork 32, somewhat exterior improvements, they put into that some of the stuff that we might consider like parking lots, sidewalks, and things like that. Utilities is a big one. There's a lot of overlap in what they do with utilities. The only difference is most of the utilities are inside the building. But they're basically the same kind of utilities. They're routed differently, but cover the same kind of utility. And then they do transportation, which is mainly parking lots and access roads and driveways. This is very close-in things. But it carries a lot of the same categorization that we see. And then at the bottom is walkway and marine construction, which could transfer over. And then we go into Omni-class, the faceted group of tables. And this is, you can read down through yourself. But this group of tables goes further into the classification. So we can see how they have taken this information and sorted it in a way that is usable during their design. And this is for project lifecycle and asset management. So if you think about this is where they gather all that information to be used downstream. What we'd like to look at here is really the table 21 elements, and that's what we're kind of talking about today, is we need a transportation classification system. Right now, I would say about to the services and elements, things that we are going to have on our projects to be able to exchange digitally, so that we can have that classification system that will help us with programs, with programming software, and just keeping organization up. So if we look at this, the way they have that set up, it's around the building again. Your substructures and services, your shell, your interiors, all of that stuff is around the building. But imagine this being a roadway of how, think about it, put it up here just in your mind. I want your thoughts to just run down the gamut of how, how this is going to be classified. You've got a roadway system, you've got a drainage system, all the things that go with it. You've got utility systems, and so forth. Looking a little closer at these tables, the way they've classified this is they use a set of numbers. Now, we know that, and as Alexa said, that computers need to exchange information the way that a computer system understands information. They're a lot better at numbers than they are with words. Although, I think they're getting really good with words. They are. So in this instance, they start with the table number. I don't know if you can see this, but the table numbers on the far left, it's 21. Look at 21, table 21 levels. And then under that, they subcategorize them with a 01 through 07, substructure, shell, interior services, and all of that we saw before. And then they keep adding to that number system for the next subsystem, and then the next subsystem under that, so that you can go through and pick that. So this is the structure, I think, that we might be looking at, something along that structure for a national transportation system. And a little bit more about software. These two tables, this is two dialog boxes out of Ribbit. I know it's kind of hard to see. They're probably really small. But the software system lets, because they have a classification system like OmniClass, MasterClass, and Unmanned, the software picks that up and says, okay, I'm going to let you associate your element that you are modeling with either a uniformat, a MasterClass, or a master format, or a OmniClass classification system. Now, I do that because there's consistency, there's predictability in the classification system that lets you, lets the program further, give you further information on that element that you're working on. So it's not just CSI stuff. They have it working so that you can pull in other classification systems. So it'd be industry standard X, whatever industry standard that you have, or an Excel sheet that you have set up that classifies further, gives information. So software companies have that ability. Once you standardize a classification system, then they can set their software up to be able to utilize that classification system to help you gain access to more functionality in your design. So having that is really going to be a benefit. And talking about benefits, let's talk a little bit about the benefits of classifications here. So industry-wide organization and standardization is going to give us a way to start down the road of a true digital exchange. Now, I work on the BIM for Bridges and Structures pool fund. It's 5372. And on that pool fund, what we struggle with is classification, because we don't have a classification system for infrastructure. We have the NBI, the National Bridge Inventory, and it does have a numbering system in there, so we can get some of it, but it doesn't cover everything, because it's for mainly for inspection and that type of work. So it doesn't have everything we need, so we can't really go on that. But if we had a classification system, that classification system would be backed up with a dictionary, which we're also developing for the project, which would go further and give us definitions of these things and further match them with other classification systems, that those components can be matched with the NBI, can be matched with the MTCE, it can be matched with any other classification system that it is in the state dictionary, which is foundational. I don't know if you were in Avicek's yesterday. He had a very good presentation on data dictionary. So very good, I mean very dense and hard to follow, but that is foundational work to a national transportation classification system. So further on that, we could have individual libraries of object families that would be easier to produce, because we could classify those, and the software companies would be able to have those available. Revit in the architecture world has something called families. Now, families are a group of items that belong to a classification. So they can go in and they know, because they're already classified, they know what information to put on this group of items, and they can make those available to the Revit user who's building the building, and he can just go in and grab out of that family this piece. He already knows what the specifications are on that piece, because the software has allowed him to put it on there and put that in place. So now he's enriched his model with all of that data, all of that information, just tags along with it. We could also do that with drainage, utilities, and so forth. So the benefit is to you, it allows the software vendor to have a classification system that they can work with, rather than working with 50+ classification systems that they're currently working with. So what we have now is we're basically given software that says, here's the software, and since you don't have a classification system, here are the tools to build your elements yourself. And then you can, what we do is we tag it with data. We name it something, that means something to us. This template is going to be for X, maybe a sidewalk, maybe a roadway, maybe a path, it may be whatever. But it's just a template, and it doesn't have any meaning until you tag it with a name. You tag it with what we're calling item type information, or property set information, or whatever type of information. You are the classification personnel for that item. So if we had an initial classification system, the software would say, well, you're going to build a roadway, all you have to do is say it's a roadway, and I'm going to pull it and say what kind of roadway you want, what type is it going to be. And we can pull that in, and it'll be tied to that classification system. And you don't have to go through all the rest of it. It's going to drag that information around. So what I'm going to do now is hand this over to Mr. McMasters and let him bring it home. All right, thank you. So, call to action. What do we need right now? Well, on this slide is spell check, because it's if instead of is. So thinking about that, when we're talking about transportation elements and classification, we need it for the different disciplines. We need it for the different pieces of that. Because when we try to review this or take this to other software, we need that common form, that classification that leads from design into those other aspects. But we don't have that. We don't have something we're looking for. It's going to match from group to group, organization to organization. So we have to think about that as we're talking about this classification. When we're talking that, We know every DOT consultant does things differently. We have different pieces that we call things, different pay items, things like that. Well, when we talk about classification, we need to forget about that as the way we're going to classify. That's metadata. That's stuff that's on. That's not what we're talking about. We're talking about the elements. We're talking excavation, pavement, maybe, we may call it wearing course at the top. Somebody may call it top course. We need to come up with a common name for that type of stuff as we go into this digital model. If everybody's calling it something different, it becomes hard to have that common review, that common deliverable. So we need to think about it as we go forward with this. How are we organizing? How are we going to take that information, establish those relationships with that data from one organization to another? How do we do that? We got to think about that. We've got to determine what's the level of detail of that. How are we going to, break it down? Do we need everything? Is there specific things that we need? We know how to build models. We know the information that the contractor wants to see. We need to somehow break that down into classification that we can use to make it easy to move from one to the other. We talk about it again, a lot of us are hoping down the road IHEEP takes that form. But we have to have a classification to use in a system like that. If we don't, it's not going to work. We have to think about it. We have to come together and build a consensus. That's part of the standardization. It's something even in my organization today. I've got to get a way to make 11 districts produce the same output. We know that's a hard task, but it's something we need if we're going to build that consistency and make models work, digital delivery work. So, uniform effort, again, I kind of talked about this, but we need to determine those element classifications. We need to establish that breakdown, how we're going to break it down, what we're going to use, how we're going to make libraries. Is everything going to fit in one bucket? No. Do we want to use that parent-child with this? No, it doesn't fit together that way. Everybody has different options, different payment setups. We can't say it's all going to be the same every time. So we have to have some sort of a backing and organization. And when we think about those elements, we know all the different organizations are going to have different problems, different metadata. PA and PA is not going to be the same in Connecticut. We're never going to change those pieces. But we need to have a common top element that we can put that metadata on. That we recognize if we're looking at other DOTs or our contractors working in multiple states, how do we get that information from one product to another, one contractor to another? That all has to be thought about. And that's where classification of elements would come in. And then we have to test that and maintain it. Is it something that's easy? No. But we need to start thinking about it. And with that, we'll go to questions.
I raise my hand with trepidation because it sounds like I hear you all are saying we need to do this, we need to go this direction, stuff like that. But I thought in some respects we were there, and I opened in data dictionaries providing that, and same with the IFC providing some of that. So when I see your hierarchy, not hierarchy, whatever the other one was, facet. Do you have it broken down by numbers and it got more detail? We already had that, We don't.
No, we don't. I think the closest that we've come to is with the benefit bridges and structures, where we created an organization structure that could become classification. What we don't have is a industry accepted standards that says, you know, table 21 is going to be, you know, bridge elements or whatever, right? We don't have that. I think what we have are the components that we don't have to start from scratch. There are a lot of engineering standards and organizational standards that could be the content to create the classification system on the tables. And so what happens is because we don't have that agreement on what we call things, your staff just spent 3 years developing a workspace to create libraries and ORD. Iowa did the same thing. Connecticut's been working on it. What if we could agree to some common elements and you wouldn't have to develop those cell libraries every time you upgraded to a new workspace? Maybe you added things that were unique to your state, but we do that in Revit. That comes out of the software. Nobody has to create those families. People append to those families today with extra items that were not part of the classification of the software. But I would love to see one day where I'm spending those 3 years testing functionality that doesn't exist today. Like, how do I review something in a model-based environment rather than creating a library so that someone can just go place and drop it in? We don't have that today, and we don't have that message to the software developers to say, we all agree that, okay, I have pay item number 500, whatever. That's not going to change. But what we can agree on is that every element that it requires payment needs a pay item property attached to that element. I think we can agree to that. So we don't have that, but we have a lot of the components. And so what happens, with IFC is that you have to manually map it every time on a project. So all the components are there, we just haven't agreed on what we're going to call it, or who's going to govern it. Like CSI governs it, they know that every so often when a new table comes up and needs to be updated, it goes through their organization as a standard organization, and they add a new element to the table. Those things need to be figured out. And just from our experience on the BIM for bridges and structures, I can tell you that the one comment that we get from software developers is like, thank you for agreeing on something. Because now I can actually put it in my product and know that it's going to satisfy a lot of people, and I can invest in that because it's going to make me money too, and it's going to make my customers happy. So, I don't know, that's a long-winded answer, but I hope that helps.
I guess not really a question, but more of a statement, and I think in large part that's why the vertical sector has been more successful at this in the last 10 or 15 years. They have, when we talk about finishes and doorknobs and windows and carpet, it's the same code across the country, and they can look pieces up and elements up. When I look up a 24-inch RCP pipe in Colorado, it's different than Texas, it's different than California. There is no uniform code that overlays everything to bring everything together. So not just organizationally, but you mentioned contractors jumping state to state and estimators bidding projects from state to state. And wouldn't it be nice if I didn't have to do training and put a bunch of risk to bid by having an estimator not exactly know what 24-inch RCP is. Maybe they don't have to pay item, but if they could just start referencing back to this master code system and then, tracing it back in that manner, and then eventually there's some mapping you could do back to every contractor that has its own WBS, and then that's how they, do their internal tracking and pay, JD Edwards and that whole piece of it. So it really all ties together. I felt for a long time, I appreciate the work you guys have done, because having a constant, consistent coding system across the board that kind of overlays everything. We have the widgets. We all use the same widgets in every state, every district. We call them something different. The pay item is something different, but it's the same thing. 9 times out of 10, the spec is extremely similar, if not the same one. So let's have that overlaying umbrella that captures it all together, ties it together.
So you actually had an interesting point there, which is being consistent across the board. And so you gave examples of other classification systems. So is there any interest in expanding the work that the vertical structures have already done to incorporate the transportation structures? Because quite frankly, a steel beam is a steel beam. A rebar is a rebar, whether it is on a bridge or a building, it doesn't really care. Are we now trying to come up with our own classification system? And then we're going to have to classify different structures and provide those classification systems depending on how that feature is used? Or is it expanding existing systems and working more closely maybe with the vertical structures market and maybe catching up with their progress implementing data digital delivery?
Yes.
I mean, in my experience,
There's talk of that, but you know, CSI is a paid product. They make money off their product. So expanding that, I'm sure that they would love someone to come in and say,
we can help you expand through the transportation system. They'd love it. Because, but are they going to give you a discount for it when you're done? No, I think it would be good, and I think that's where you would start. You would start with the people who are already doing those kind of things and say, this is what we need. Is this on your radar? Is this what you're going to do? Can we collaborate with you to get this done? We understand we need it. It's going to help us in what we do, and we want to help make it happen. So yes, you're right. That's a good place to start.
I think it is CSI. For the most part, the vertical world abides by CSI and categorizes. I mean,
so they do abide by CSI for the most part, right? And I think taking our projects and slicing them and squeezing them into that structure is a good place to start. You know, Division 3 is concrete. So it's going to be not one category, it's all transportation and civil infrastructure that we're used to. This is going to be concrete, over here is going to be steel, over here is going to be earthwork. It's broken up a little more, we might think splintered at the moment doing that, but at the end of the day, we're pretty smart people. We can figure out how to look at that.
I think that that's the point, right, of having this conversation and starting. There are just so many ways that you could skin this cat, right? And the idea is never start from scratch. There are things in place. What it is important, though, is how you govern those tables and how you're going to tell CSI. If, let's say we all agree, CSI's like, hey, you know, we've been wanting, in fact, they've been wanting to do infrastructure tables, they just don't have any infrastructure SMEs to help them with it. And that's why they've never done it. But the main thing for all the DOTs is really how you're going to govern as an industry those tables that go to CSI. What's going to be the process for you guys to come together and say, hey, CSI, I need one more element to that table. Can you add it? Who's going to make that decision? And that's the kind of thing that the software vendors are looking for. Is it going to be Bill? Is it going to be, you know, Michigan? You know, is it going to be Washington? You know, like, who's it going to be? And it's probably going to be the Ashton membership, right, as a whole. But you don't have to actually do the work. You just have to figure out how to govern it and be smart and use somebody else to do the work that is already being done, right? But those two components are super important, is why, how, when you're going to update things that are useful to all of you, and then who can do the work the fastest.
Just wanted to say, unfortunately, I don't think anyone's in here from the vendor side, but you're not. You're an engineer. Okay. So there's skin in the game for the vendors too, right? I mean, for us to do the hard work and develop these classifications and work this out, I think it's on us to work with Asheville, though, right? So we have to do that, not them. But there's a tremendous benefit for them to get us all on one page and to move into this direction. So, are they at the table in this discussion? They are. They are?
There are some, I think they're waiting for your leadership, though. You drive the market, right? If you think about, we're recording this, so I better use the microphone, just for the recording part of it.
But if we think about how the market comes to be, 5 years ago, the apps that are available in the app stores didn't probably exist. But there was a demand for it, and someone came up with an idea, it's like, and it sells. So if the industry demands, the market will follow, but it has to make sense, right? For you guys to invest in your software, too. You don't want to do it 50 times. So it's, you know, and that has been the biggest lesson learned through the BIM for Bridges structure, is that we brought them to the table very early on, even before we knew what we were doing. And John has been involved in that project from the very beginning. I wasn't. But we have an incredible amount of participation and collaboration that I have never seen before in my 20+ years of doing this. But we are finally inviting everybody to the table. And I think that is super important. But you need to lead them, right? You need to make sure that, like, they're like, okay, we agree, this is what we want. Now, like, really, show me what you can do. Anybody else? Perspective from my vendor friends?
I'm from Open BIM platform. I think we were working with Federal Highway. I was not with the company back in 2015, but I was attending the meetings. I think and we were trying to develop these library components, bridge library components. We were focusing on those things. We were trying to come up with these parameters even back in 2015. I think everything that we are doing here for IFC, for standardization, is valuable in theory. But after developing that library for the last 8 years, so after that Federal Highway project, we become like a private entity, and we are basically trying to help our consultancy firms, and we are creating parametric library components on the cloud for the last 8 years.